In question 7, a scientist is using a double slit arrangement to find the wavelength of light from a laser. In A, they have a double slit of known separation. We need to describe the measurements they will take and how they will use them to find the wavelength of light, discussing any safety precautions and how to arrange the apparatus to improve accuracy. Well, they will need to measure the distance d between the slits and the screen using a meter rule. This distance should be as large as possible, around 2 to 3 meters, to improve accuracy. They will need to measure the separation W of the bright fringes on the screen. They will do this using a vernier caliper, measuring as many fringe spacings as possible, around 10, dividing the length by the number of fringe spacings measured. They should measure to the center of the bright fringes. Performing the experiment in a darkened room will make the fringes clearer. They can measure fringe separation for a range of screen distances, plotting a graph of fringe separation against distance to the screen. The gradient of this will give the wavelength over the slit separation. They would have to ensure nobody could look towards the laser and that the screen was non-reflective for safety. A safety notice should be placed on the door to the room. In B, we need to explain what is meant by coherent light sources. Well, coherent light sources have the same wavelength, and therefore the same frequency, and a constant phase difference, which can be 0. In C, we have this arrangement with a candle and a screen. We need to sketch and label on the diagram the arrangement Young would have used to obtain his interference pattern. Well, he would have had a single slit, followed by a double slit. In D, we need to state two differences in the appearance of the pattern observed with a laser and that produced by a white light source such as a candle. Well, the laser will produce narrower fringes than the candle. The laser will produce fringes of just one colour, whereas the candle will produce fringes with a spectrum. The laser will also produce brighter fringes than the candle. In E, we need to explain how the wave theory of light accounts for the areas on the screen where the intensity is a minimum. Well, where the intensity is a minimum, the light from the two slits arrives in antiphase and destructively interferes.